the faculty startup venture committee and fellow VIT technology business incubator. I have great pleasure in welcoming Professor V. Ramgopal Rao, professor and immediate past director of IIT Delhi, who had a well-accomplished career and particularly in the innovation and startup space. And so VIT has announced its faculty startup policy about 7-8 months back, July 2025. And there has been a considerable interest from faculty members and research scholars to pursue the path of entrepreneurship. And many times it's also difficult for someone to do multitasking apart from the academics, research, and also the consulting. One has to pursue the path of entrepreneurship and also excel in that. It requires a greater intellectual stamina and the will, and also other network and resources to pursue that. And so in that way, the committee and also the organizing team felt that a person of Professor Rao's stature, it will be very motivating for some of us to emulate and also get some directions as to how one can manage apart from the core academics. So I also have great pleasure in introducing him formally before we start the session. And Professor Rao is a professor of electrical engineering at IIT Delhi. He served as the director of IIT Delhi for close to 6 years, which was a significant innings and significant achievements during this period. And before joining IIT Delhi as the director, he was Professor Kelkar, chair professor for nanotechnology at IIT Bombay. He has over 480 research papers, 49 patents where he's an inventor, and 18 issued US patents, and 13 of that have been licensed to industries. He has co-founded 2 growing deep tech startups at IIT Bombay, NanoSniff and Soil Sense. The products are available in the market and in the government's e-marketplace portal as well. And research and leadership contributions have been recognized with over 35 awards and honors in the country and abroad. He is also a recipient of 3 honorary doctorates. The notable recognitions received include Shanti Swarup Bhatnagar Prize, Infosys Prize, IEEE EDS Education Award, Excellence in Research Awards from IIT Bombay, DAE and DRDO, Swarna Jayanti Fellowship Award, IBM Faculty Award, Best Research Award from Intel Asia Academic Forum, Techno Visionary Award from Indian Semiconductor Association, JC Fellowship, National Fellowship, among many other awards. So he was also an editor of IEEE Transactions, distinguished lecturer IEEE Electronics Society, Electron Devices Society. He was born in a remote village, Kolhapur, Mahbub Nagar district of Telangana, born to lower middle class parents and studied until 12th standard in Telugu medium in a rural setting. Carries strong family values, a rural connect, and extreme empathy towards all living beings. Sir, I also recently read your LinkedIn post appreciating your native student getting into IIT Madras, and it will be a great honor for us to learn from your experiences, sir. So over to you, and once again, thank you for accepting our invite to address our faculty members and researchers. Over to you, sir.
Thank you, Dr. Balachandran, and I'm very happy to be here with all of you, speaking with the VIT faculty. So I have made a presentation, so let me share that. Yeah, you're able to see my presentation, right?
Yes, sir.
Okay. So I think since you have given the title as faculty as startup founders, so I will also focus on this aspect. What is that we need to do so we can start enterprises? And if you look at R&D, I think India is doing pretty well. We are ranked 3rd in the world when it comes to the research output, the knowledge generation. So we have a world share of 5.31%, while the China and and US are way ahead of us, but we are still at the third position. And this is also something which is improving. India is growing at almost like 11% in scientific publications, while the world average is 4%. So this is what has led us to overtake many other countries in the recent past. India doesn't still spend enough money as a percentage of GDP, while many developed countries, you see all these Germany, South Korea, US, China, many of these countries are spending anywhere from 2% to 4% on their higher education. India is stuck at 0.6 to 0.7% of GDP. So we spend far less compared to any other country, in that class. And despite the low spending, I think we still do pretty well when it comes to the research output. Papers written per dollar spent, India ranks number one. So that way, I think we have become experts at converting the money that is given to us into publications. I think that part of it, we have become pretty good at. And what is probably missing is the reverse, which is translating that knowledge back into wealth. I think that is where we still have some way to go, and things haven't really improved significantly, even since the days of Sir C.V. Raman. Even the Raman effect, which was invented entirely in the country, there are still all Raman instruments which are imported. Not a single Indian company is in that space. So some of our finest science and technology, we are not able to convert that into anything which is tangible, as a market. So I think that is a problem that we currently tend to face. So how do we solve this? I think that is what my talk is all about, and that is where the faculty entrepreneurship becomes very important in our institutions. I am very happy that VIT has come up with a policy for faculty to become entrepreneurs. So I think for this translation to happen, the societal problems need to become projects in HEIs. I think in higher educational institutions, we need to convert the societal problems into projects. When that happens, I think the next step is, of course, the entrepreneurship and translation and all of that. So that's the first step. And India, in fact, doing pretty well. As I mentioned, I recently looked at Scopus. India's ranking is, for example, in sensors, we ranked fifth in the world, and for our AI ML, we ranked third in the world. And we are also receiving good amount of citations now. Even our H-index as a nation is also improving pretty significantly. And so that way, I think India has that scientific culture. I think more money, if we receive, we can write even more high quality papers and more publications. All of that will also result. In fact, in my list of, while comparing the Scopus data, I also noticed VIT figuring very prominently in some areas, particularly in the sensors. There seems to be a lot of research happening, in VIT with VIT affiliation. So I think, some of these good things are now beginning to happen. And in the sensors, just to give you, this is happening in almost all the sectors. But in sensors, if you see, this growth has been in the last decade or so. So that exponential growth that you are seeing in terms of publications has happened in the last decade. And even the citations have also started growing, in the last decade. The dip here is because of COVID. So I think we should disregard that. But otherwise, we are on a major exponential kind of a growth, in these areas. So which is pretty good. But what we are not doing very well is, filing patents. I think, if you look at nanotechnology is my area of expertise. For example, in nanotechnology in 2009, when I was looking at the data, for patents for 15,000 publications. So that is like one patent for every 300 papers or so. I think that is a problem that we are currently seeing. And so we need to protect our IP much better. For the ratio of patents to publications, I think that needs to go up. So we need to protect our IP, more aggressively, before we publish it. So therefore, the sequence is always patent, publish, and prosper. So the prosperity will come through startups, technology transfers, and all of that. But patenting needs to happen before a publication happens. I think that is something which is important for us to do. And even countries like, look at South Korea. So that is again for 9,000 sort of papers, they have filed 1,100 kind of patents. So I think that is something, that's the reason why a lot of technology development happens in those countries, while we tend to keep on writing papers after papers. So that is something that needs to change. So therefore, when you look at any educational institution, whether it is VIT or IIT or any other institution, there are three aspects to what we do as an educational institution. The first one is, of course, education. And when you say education, you are disseminating the knowledge that is available already. So this all captured in textbooks or research papers, and then you take that knowledge and disseminate to the students. So that is one thing where we all tend to do pretty decently. The second aspect is knowledge generation. Even there, I have shown you that in the last decade, we seem to have grown exponentially, and so that way, we are also pretty good when it comes to generating knowledge. So that's also pretty good. But innovation is where we seem to be, significantly lacking, as I showed you from the patents and all of that, which is one of the metrics for innovation. If you are not even protecting your IP, I think translating that IP into a technology or a product, will not even happen. So therefore, innovation, a good measure is patenting. While for knowledge generation, as we all know, the publications and the citations are good metrics. So when it comes to innovation, we seem to be pretty, poor. But how do you convert knowledge into innovation? So what is innovation? Innovation here, I am defining it as the value generated for your research. So you are writing all these papers. I have written, let's say, 100 papers. Now, what is the value generated out of these 100 papers? And if that value is just, publishing those papers and just that count, then it's not of any significance to anybody. But if people are citing that research, I think that is one way you can count the value. And if people have used that research to develop products, I think that is when it actually becomes innovation. And so value creation out of your research is what I would define as innovation. So when does knowledge become innovation? That is when you bring relevance to your research, that if your research is actually solving a problem that exists in the society, then you are, of course, innovative. And because once you find a solution to a problem, the next step is, of course, the delivery, so that you take this solution to the society, and whether through a startup or through transfer of technology to a company and all of that, through a variety of ways, you will take this technology to the society. And so therefore, the knowledge to become innovation, you need to put in place proper structures when it comes to bringing relevance to your research, and also when it comes to delivering the solution to the end, the stakeholders. And but it is not to say that the basic research is not important or blue sky research is not important. I think those people need to continue to do basic research, because today's basic research is tomorrow's technology. If we cut down that pipeline of basic research, then there won't be any technologies in the future. So all technology that you see today started as a basic research at some point in time, and therefore the basic research the must continue. And but in places like IIT or Vellore Institute of Technology, so we are all technology institutes, we are engineering institutes. Here at least 60 to 70% of faculty must worry about innovation as part of the as part of their activities. So that's what is the thing. But how do you bring relevance and delivery? These are things which, for example, we tried at IIT Delhi pretty successfully. Now, one of the things I always when I look at the way the academia today functions, is how do you generate research problems in academia? So when a PhD student joins you, now where do you find that PhD problem for the student? I can assure you, at least in 70 to 100% of cases, those problems originate in the library. So the first thing we do when a student joins, after all, I'm also a faculty member, and I know how system works. So the first thing the student does is goes to the library and then starts doing a literature review. And then the student says, reads some 30 papers, 40 papers, and says that, sir, this is done, but this is not done. And then the student starts working on what is not done, and then fills up the gap which existed in the literature, publishes a few more papers, and that is how, at least depending on which institute you go to, 70 to 100% of research problems actually, originate in the library, and those problems which originate in the library also end up in the library, because by the time the research papers appear in library, remember there is already a lead time of at least 3 to 4 years kind of a thing, because the work would have happened 3 4 years ago by the time it comes to library, and then you add some more things, and then so the time lag always continues. Every time you are picking these problems from library, you are behind by the rest of the world, at least 3 or 4 years kind of a thing, and that way you will never be able to bridge the gap and become a leader in any particular kind of an area. And this is primarily the India's problem. How else can you find problems? The one way you can find problems is by observing issues in the society. So, for example, there are so many problems in the society. I mean, infinite kind of issues that people face. And, can you, for example, understand the problems of farmers, understand the problems with electricity distribution, understand the problems that somebody in the industry is facing when it comes to manufacturing, understand some of these issues that are happening there, and pick up them as research problems and then provide a solution. So that is where immersion programs help. As engineers, we tend to get disconnected with the society, pretty easily, because while working with machines, working with students, we really create a nice ecosystem, a cozy kind of a group, and we never even interact with anybody outside of this group, and in the process the same ideas get repeated, and you don't have that fresh breath of air when it comes to picking a new problem or anything like that. And so therefore these immersion programs we found are very useful, and immersion programs are where the faculty and students spend time in places where there are real problems. For example, IIT Delhi faculty and students spending time in All India Institute of Medical Sciences in Delhi, and IIT Delhi students and faculty spending time in rural areas. We created these rural internship programs. Now we launched a program called GRIP, Grassroots Innovation Program. And in all of these, the faculty and students go and stay at one of these places, whether it is hospital or industry or rural area or an NGO or anything that you name, and then spend 2 weeks to 1 month to 2 months there, and institute facilitates many of these, and then they understand the problems that these people face, come back and then try to use IIT resources to actually solve those problems. So that is how you can pick up some nice problems from society. Another thing we have also done is strengthen our connect with between engineering disciplines and the humanities faculty. There are pretty good humanities faculty members who work with a variety of people in the society, and now if they understand many of these problems very well. So we launched a grand challenge initiative some time ago, where we are now connecting the faculty in the humanities department with the engineering department. So humanities faculty members take a lead in defining these problems, and then they involve the engineers so that they can finally deliver that as a solution. So these are the things which you need to do in order to pick up problems from the society. What is the other way? Of course, this industry thing we all know about, and academia industry collaborations are important primarily to get to for the faculty to work on the right kind of problems. More than the money, what is important is if you interact with industry, you get to know their real world problems. So before others publish those papers and all that, if you knew the problem ahead of anybody else, then you have a edge over others. For example, in the US, many of the universities, many of these big companies, of course, US has all these giants, among industries. So that these now big companies going and talking to a faculty member, engaging a faculty member, saying that, in this advanced technology node, I'm facing this problem. So can you solve it? The faculty member, of course, work gets to know that problem earlier than anyone else. And also whatever solution the faculty member develops, some of it the industry can use, but in some form by hiding, by masking some data, you can publish that as a paper in a top journal or a conference or, things like that. So that is how, they tend to be always ahead of others when it comes to, getting to know the problems first. And if you know the problem, ahead of others, of course, you also can, become a leader in that particular area. So this is where the connections with industry are important. At IIT Delhi, we did multiple things to strengthen those collaborations. When I joined as a faculty, as a director in 2016, when we looked at the IIT, profile, about 70 faculty members were had active collaborations with industry. And by the time I left a month ago, when we looked at it, we had about 300 faculty members with active collaborations with the industry. So from 60 to 300 is the kind of improvement that we could make. And that happened mainly because of, we created an industry day. Every year industries come, and then it's an open house for industries. We have a tech park now, like what IIT Madras has. We created centers of excellence which are funded by industries. And this professors of practice, which we implemented at IIT Delhi about 3 years ago, is now working very well. So there are in every department up to 10% of faculty can be professors of practice. So these people can come from industry. They need not even have a PhD, but then they have 25, 30 years of experience of working in an industry, and they come and work with faculty, and then they are transforming the culture in many departments now. The joint appointment with industries, industry sabbaticals for faculty. The FIRE is a scheme. You said there is a kind of a policy now at VIT for faculty to become entrepreneurs. So this faculty innovation and research driven entrepreneurship is a scheme we started at IIT Delhi. Of course, faculty becoming entrepreneurs has been happening, those policies we had for almost like 2 decades. But this FIRE scheme is something that we launched about 3 years ago, where we said that under the faculty innovation and research driven entrepreneurship scheme, if a faculty member at IIT Delhi wants to become an entrepreneur, we give 50 lakh rupees as a grant. So that is something that we do. And then we also give 1 year sabbatical, fully paid leave for the faculty member to work on the company or the startup. So that 1 year sabbatical we give, 50 lakh rupee grant we give, and we also provide access to the faculty member, to all the facilities that exist on the campus. So that way the faculty member can work for the startups by taking this grant and by making use of that leave, and also, by making making use of the available resources on the institute at a concessional kind of a rate. So these are the things, which are now encouraging many faculty to become entrepreneurs. And in some departments already, 1 in 5 faculty members owns their own company. And at the institute level, that is the kind of a target we have now. I hope we will have at least 1 in 5 faculty members, being part of a startup or being founder of a company kind of a thing. So we also started a PhD incubator for our PhD graduates, to become entrepreneurs. There is also a separate incubator for them. So some of these initiatives have helped in a way scale up, those kind of connects with the industry. And then finally, these interactions with the strategic agencies, whether it is DRDO, ISRO, we now very consciously connected with these agencies at IIT Delhi. About 4 years ago, we started a joint advanced technology center with DRDO. We started a ISRO cell at IIT Delhi about 3 years ago. So to all of these schemes now at IIT Delhi today, at least 100 faculty members and about 150 PhD students are working on DRDO funded, DRDO supported problems. So what it means is whatever research they do now is helping these strategic agencies, directly. So I think some of these are the ways we need to, pick up problems rather than, only picking them up from reading papers and then, just picking up a problem to fill the gap that exists in the literature kind of thing. I think these are the avenues that we need to strengthen in our academic institutions and for innovation to thrive. And if you ask me, what are the 5 major areas where institutions need to focus? I would think these are the 5 T's, I call them. And the information technology is a platform which is there everywhere now, and India is a world leader in information technology. Just to give you a perspective, India IT exports in 2019 were 137 billion US dollars, and Saudi Arabia crude oil exports were 133.6 billion dollars. So that's the kind of a market share we have. What Saudi Arabia does as crude oil export is what India exports as its brain power. So that's a kind of a strength that we have in the IT. And even in the biotechnology, we all know now that India has done very well in terms of finding vaccines and dealing with the COVID, and that's because of the strength we have in the biotechnology area. In fact, we are the world say. And in the nanotechnology, we seem to be doing a lot of good research. We are ranked 3rd in the world, but I think we haven't translated much of that knowledge into products. There are no major companies in India selling these nanotechnology products. So this is one thing where that knowledge translation needs to happen right now. And finally, the 4th is the cognitive technologies. So this is where AI, ML, blockchain, all these technologies I would place. And India is ranked 3rd in terms of the number of papers written in AI, ML kind of areas. But in terms of citations, also we are doing pretty well. But here we need to scale it up further. We again need to apply this knowledge to real world problems. So that's one thing that needs to be done. And finally, the quantum technology. So there is a strong tradition of basic research in India. And in the future now, everything will have quantum, everything will have AI, ML, everything will have some component of nano, just as we have IT now everywhere, and the biotechnology, also there everywhere. So therefore, I think as IT and BT have become part of our lives, you get up in the morning and you have to use these technologies for your survival right now, whether it is at the workplace or to remain healthy. I think IT, BT have completely transformed the human lives, and the same thing is going to happen with nanotechnology, with cognitive technology, and with the quantum technology. So therefore, no institution can stay outside of these 5 T's, and needs to have the centers and centers of excellence and a large group of people working in these kind of areas. And having said that, the nanotechnology, as I said, is my area, and I have already taken 30 minutes of time, so I will skip some of these details. But nanotechnology is all dealing with the nanomaterials. Of course, you can go to Google and search what is nanotechnology, and you get all those details. I don't need to explain all of this, but I will give you my own examples. So I started applying nanotechnology to sensors. So because nanotechnology, one of the good things is the surface areas are huge. So therefore, you can make sensors which are very sensitive. And also, if you know how to engineer these nanomaterials, you can even bring in selectivity. So therefore, large surface areas giving rise to high sensitivity, and then the engineered nanomaterials giving rise to selectivity. So I always believed that nanotechnology and the sensor research goes hand in hand. And if you look at the human body, primarily we have 6 ways we absorb information. So the sight, hearing, touch, smell, taste, and of course this is something that like the GPS, in our brain, our sense of location is what is proprioception. That's a 6th sensor. But in a mobile phone, if you look today, you have all these 4 sensors which are pretty well developed. But what is missing in the consumer electronics part is the smell, the electronic nose platforms, and the taste, the electronic tongue platform. So I as a researcher, started to see, can we develop an electronic nose platform? So that research I started way back in 2006, 2007 kind of a time frame. And we also started to see that the Internet of Things, where sensors play a primary role, are like a big markets now. People are talking of a trillion sensor visions, like $1 trillion market for the sensors alone. So I think sensors, I believe, is one very important area for the country and also for the institutions. Even looking at the number of sensor systems in the market today, there are like 26.66 billion in 2019, and by 2025 they are saying there will be 75 billion sensor systems, the IoT nodes working in the society. So I think it's a big market. We need to be able to capture a part of this pie. Now, with that intention, I started working on the sensors. Otherwise, I come from a CMOS background. I work for semiconductor industries kind of a thing. So then I consciously moved to sensors because I saw that sensors is one thing where you can apply the technologies to the local problems, and then you can either save lives or you can make things better for farmers and for medical doctors and patients and all of that. So I consciously started working on sensors in addition to my primary focus area, which is the CMOS kind of technologies. And then when I started working on sensors, the question that I asked myself is, what are the kinds of sensors that I want to develop? And like I said, if you look at it, there are multiple avenues. Agriculture is one where you can develop lots of sensors, and then you can also develop sensors for healthcare. The diagnostic technologies are still absent for many diseases, and similarly the security is a major concern. You can have these networked kind of sensors for security applications. Energy is a big issue, so therefore the renewables and then the piezoelectrics, that again is a huge area, because to make these sensors work, to generate their own power, I always believed that an IoT node needs to find its own power. Connecting it to a normal power line will require a lot of deployability issues. So I wanted to develop these sensors which generate their own power. And similarly, even the water crisis, saving water is something which is very important for a country like India. So therefore, if you are looking for sensors, you can develop these sensors in multiple domains, and also make them low cost. That's a very important to have that market penetration. So I started working very consciously on the sensors area. Starting from 2006 kind of a time frame. And one of the very first problem I picked up in the sensors area was a cardiac diagnostic system, and that came about through our discussions with the medical doctors. This is not something that we went to library and discovered kind of thing. So we started interacting with the medical doctors, a group of us, faculty members, and including those interactions, we figured out that this is something doctors desperately need, sort of thing. And once we were able to identify that desperate need in the medical community, then we as a group started working on the problem. And so we started looking at the diagnosis, detection of the heart attacks, early prediction of heart attacks. So we started looking at detecting some of these cardiac markers like troponin, CKMB, myoglobin kind of a thing. And so we developed sensors for them, a complete lab on chip kind of a technology for detecting some of these cardiac markers with the tabletop electronics. And we developed a sensor platform, which is a cantilever based platform. All this work is published, so you can check my webpage and you will find all these papers. So on this platform, we improved it by applying multiple nanotechnology principles. We developed the complete electronics. We developed the complete prototype. And so this is a working prototype which still works in the laboratory. And then we transferred the technology to a startup. We started a company, NanoSniff, at that time in 2011, and we transferred this technology to NanoSniff. And NanoSniff was able to commercialize the platform behind this, but they were not able to commercialize the actual technology for cardiac diagnostics. And that was because of the issues with working with the doctors, the medical trials, the hospital trials, and they were not able to manufacture, they were not able to actually get this product into the market. And but the platform which was behind the sensor, the cantilever platform, many institutions have bought this. That's a OmniCant platform, and now many they have been able to survive with that platform for some time. And then once we developed that, we started looking at other applications of the platform. And one of the things we started getting into was an electronic nose platform for explosive detection. So we never used the similar kind of a platform, and then we now developed molecular recognition of explosives. We did a lot of work on that. If you look at my papers, you will find very interesting papers on how do you recognize vapors of explosives. I spent now almost 10 years in this field. So now we again worked on developing these molecules, coating them on the cantilevers, binding them to the vapors of explosive. So we developed this XSNIF, an electronic nose platform for doing this. And this is one of our very recent papers, multi-channel analog signal conditioning and pattern recognition for explosive sensing. And so we did quite a bit of interesting work on this. And now we then transferred this technology to SCL kind of a place. And then it can recognize up to 80%, and it has about 75 to 80% accuracy, but the remaining 20% still became a challenge for us. And that is when we started exploring other kinds of platforms. And for example, this paper captures some of these nano electromechanical relays for vapor phase detection. And here we did some very interesting work on MEMS based sensors, and this we were able to make it work in the field for explosives, and this we launched as a product. So this, what you see here as an explosive detector, is 10 years of work, and you can actually search on Google with the name Nano Sniffer. It can detect explosives in 10 seconds kind of a thing, and it can detect all kinds of explosives. And so this is a patented technology. We have been able to obtain the US patent. The US patent has been granted on this, including the European and Indian patents. So now it's a patented technology. We are now actually exporting these systems to even countries outside, and many leading players in the explosive detection space who all use the spectroscopy based technologies. And this is a microsensor based explosive detection, which is a completely disruptive technology which no one else in the world has. And that now is a product, and this we Government of India, Ministry of Education launched it, and so now it's many airports and other places are actually buying this. So this took us. So we tried multiple approaches. Some worked, some did not work. In some, we were not able to meet that 100% kind of requirements. And but finally, to all the trials and errors, finally we were able to develop a technology that works in the field. And then once we developed an explosive detector, now you can develop an IoT node, and you can put it in the buses, trains, and you can generate power from the vibration. So most of my research currently is focused on developing an IoT node out of these sensors. And so a lot of interesting work happens in my group, and we also publish many papers related to developing this IoT node for explosive detection and all of that. And then of late, about 3 years ago or about 4 years ago, we started interacting with agricultural scientists and also with farmers in the field. And so we figured out what are the issues that the farmers are facing. And our studies showed that the precision agriculture is a way to go for the country. But for precision agriculture, you need lots of sensor systems which are low cost and which are all developed keeping in mind the social economic background of our farmers. So for example, all farmers are given the soil health cards, and they need to monitor in the soil their micro and macronutrients. But where will the farmers actually go to get these tests done? Today it has to be done in an agricultural lab and all of that. So after I moved to IIT Delhi, we started a joint project with IIT Bombay, and with the goal of developing 4 prototype test systems to basically cover all the micro and macronutrient parameters which are present in the soil health card. And that is something which a 10th standard graduate in a village can actually perform, sort of thing. So we developed these systems, and now we actually have, after 4 years, we started a company, Soil Sense, a couple of year ago, and Soil Sense is now commercializing these technologies, and they already have about 140 installations of these technologies. And it is a weather station, and it also can do multiple parameters in the soil like nitrates, phosphates, and potassium, the NPK sensors they have right now, and which they are commercializing. And they already sell these systems now, the entire weather station systems they sell, and it's a growing company. It's doing pretty well. They are able to now work with multiple farmers and multiple companies in the agriculture space. And so through this process, we are now developing more and more prototypes, and that's a cultural change that has happened. So while we publish papers, in all these areas, but the goal is to put all of that together to develop a prototype at the end of the day. And NanoSniff now is doing pretty well. So NanoSniff has raised quite a bit of money from investors, and now the Omnicant, the cantilever platform, is commercially, they have launched it for the past 5-6 years. They have been selling that, and explosive detector is now launched a year ago, and which is also now doing very well. The cardiac thing is what is on a back burner, but at some point, even that they would like to revive. But right now, the company is growing because of Omnicant platform, which we developed, and the explosive detector, which is now commercially available. And so this is how the Omnicant platform looks like. And these are all the explosive detectors and all that. Soil Sense is also doing very well, my second startup, and they now are in the agriculture space for precision agriculture, and so they have multiple installations and all of that. And therefore, if you look at it, the way I see as a researcher is India is opportunities, and these micro MEMS batch processing kind of approaches are ideally suited from the cost requirements, because if you process them, the micro sensors, the advantage is when you make them, you make 1,000 of them, because you do that on a wafer. And so we built those facilities now, and there is a prototype manufacturing facility available now in our institution. So that way, these are what we use for most of our sensor requirements. The goal is to target the bottom of the pyramid population. So the 100 million of 1.3 billion is what these multinational companies are targeting. But what we are targeting is the farmers. 50% of India is into farming, and what are the requirements these small farmers have? Can we develop solutions to these farmers? In all of this, a business model innovation is as important as technology innovation. So therefore, your business models also need to go hand in hand with the technology, and all the the ground realities need to be kept in mind. The local R&D for product development is essential, because eventually the costs need to be something which are affordable to which is affordable to the farmer or to the end user. So therefore, the local R&D is very important for all of these sort of technologies. And fortunately, now there are multiple Government of India initiatives, and it's important to make use of them. Most of my startups, or both my startups, have got funded by BIRAC, and they were able to build the entire technology and commercialize them using BIRAC kind of grants. And that's important, because if you early stage, if you go to private investors, then you dilute the equity so much that many people lose motivation to even continue with such a company. So I think I always believe in this locally engaged and globally networked model. So I think the problems you pick up locally, and then you work with all the best people in the world, to generate the solutions. So that is a kind of a model that works very well. So I think innovation, my experience is the top-down product-oriented approach is the key. So if you are just developing solutions, it's always a research which is like, you have solutions looking for a problem. I think that approach, oftentimes doesn't work. The solution looking for a problem is, something what we all do, but the problem looking for a solution to a problem is something that we should be, doing more often. And so that is where the total a top-down product-oriented approach is the key. You work on the platform development. That is where you can write papers. That is where you can file lots of patents, and you need to protect the IP as early as possible, because if you are not protecting IP, there is no startup later, because if you don't own IP, no investor will ever invest in any of these companies. So protecting IP is very important. And you also need to mature the technology in academic environment. We did that mistake with the case of my first company, NanoSniff. I thought we were in a hurry to start a company. And once we started a company, in 2011, it was difficult to raise funds for the company, and there were not many schemes available for startup funding and all of that. So that we were a bit premature in starting the company. So NanoSniff struggled quite a bit, but eventually survived and able to sell the systems and develop the products. So that mistake we corrected in our second company, the Soil Sense. In Soil Sense, we developed everything in academic institution. And once we are ready with the product and everything, then once we started a company, within 6 months, they were able to actually start selling. So it's important to therefore mature the technology in an academic environment, given the lack of ecosystem for VC funding for technology startups. And there are many government of India sources now available for funding these startups, and we must make use of all of them. And I also don't believe that only professors and students can build a company. You need a team. The team should have people with marketing experience, people who are experienced in developing products. So you need to form a right team with the right set of people, so that you can develop products and finally take it to the market. And you need to work towards the increasing the value of equity, not fighting for the equity. I see many companies failing because the founders don't get along with each other beyond a point. And it's important to have clear agreements in place from day one, so that those issues do not arise. And it's also important to involve students in the enterprise. It's a strong motivation for them. Both my companies now, NanoSniff and Soil Sense, are run by my ex-PhD students. So they have graduated. Now they are CEOs of the company, and they are running both the companies. And also look for areas where there is a great domestic demand. And there are many areas where you have huge demand in the country, and that is where you have fewer controls, and you are aware, awareness about markets, the networking is easier. I think that is where we need to be able to develop these products. And for any startup, I always say that passion, patience, and perseverance are important. I mean, if you are not passionate and if you don't have patience, these things don't happen overnight. Whatever I showed you is the work we started in 2006. So as you can see, it's already 16, 17 years of research to reach a stage where we have two startups, and with the products in the market and with multiple platforms. I think all of this won't happen overnight. So it requires that sustained kind of an effort, but a very focused and directed kind of a research. That is what the patience is important, and perseverance, because in every case there will be failures. We, for example, developed the cardiac diagnostic system, but it did not reach the market, and we realized the problems, but we did not stop there. We focused on other things using the platform, and we were able to get the other things earlier into the market. And now using the resources that we have available, now we are still working on the things that we want to do. So therefore, I think the perseverance is important, and so these three P's are required. I think I believe the academic institutions need to follow this idea factory kind of an approach. This unlike minds is important. If we interact with the same people day in and day out, nothing is going to change. We will only have the same ideas every day. So that won't make us entrepreneurs. We need to start interacting with people who don't think like us, who don't, who come with a completely different kind of a background. And that is something which is very important. So when I say unlike minds, people with different cultural backgrounds, having foreigners on the campus, discussing with them, sometimes is very important. People with different disciplinary background. I, as an electrical engineer, have written maximum number of papers with chemists. Chemistry, I found, is very important for all these senses area. I would have written over 50 papers in top journals, using chemists as the co-author. So that different disciplinary training and interactions are very important for you to develop new ideas. And the different attitudes, that is where the industry interactions become important. So for academic institutions to become idea factories, you need to bring people with, who are unlike each other, and then, make them create awareness avenues for them to collaborate with each other. Otherwise, electrical engineers working with electrical engineers is not going to change anything. And once you have those ideas, of course, you need to create an ecosystem for high-tech startups to multiple schemes. Central facilities, space, faculty appraisals need to take that into account, the initiatives for supporting startups, the PhD incubators, student startup action plan. We did multiple things at IIT Delhi to strengthen the startup ecosystem. And now, all those results, we are actually seeing. And this has also resulted in a huge growth in the institute, whether it is sponsored funding or COEs or funded research projects in all respects. IIT Delhi in the last 5 years, for example, we filed more patents than the previous 55 years. And that kind of a growth has happened because I think, you need to drive this ecosystem, and which is important for doing that. And even during the COVID time, IIT Delhi did very well, whether it was a low cost RT-PCR kit or an antigen kit. All of that happened because of the support from the institute for startups and for these ideas to turn into prototypes. So much of this research we internally funded, and now those faculty members have been able to raise a lot of external funding. But the seed grants were very important in order to trigger that research. And we also have at IIT Delhi multiple initiatives for immersion ideation, for product development and validation, for pilot scale development, for market, for training and mentoring, for innovation awards. I think through all of these ways, we now support our faculty and students to become entrepreneurs. So it's important. This is all done by FITT, the Foundation for Innovation and Technology Transfer. I think it's important to provide the support at all levels to the people. So I think this is my last slide. I think I particularly think this multidisciplinary approach is important in academic institutions. And then the locally engaged, globally networked model works very well. Innovation and entrepreneurship need to become major drivers in academic institutions. So we need to become a demonstrator for conversion of knowledge into wealth. And a student-centric and flexible curriculum. A lot of out-of-class learning needs to happen. Ethics, leadership skills among the students community, and even for faculty, imparting those skills is important so that they can become good entrepreneurs. Diverse set of faculty. I think having all faculty with a template kind of a CV is not going to change anything. We need to have diverse set of faculty, people with different kinds of experience, serving on the faculty. Those interactions often tend to be very useful. And we need to become hubs for industrial R&D through tech parks, to R&I parks, industries coming and doing their research on our campuses, engaging with faculty and students is also one way we can drive the innovation. So this is all I have, and I will be happy to answer any questions you may have. Thank you.
Yeah, thank you very much, sir, for this insightful and important information. So we have about 10 minutes. So shall we take some questions from the participants? Yeah. So if anyone,
Please do.
yeah. So
good morning, Professor. This is Dr. Arun from the School of Electrical Engineering and also currently the Dean Academic Research. There is a big question from all over the entrepreneur, how to sustain into this the fast phasing the technological work with the innovations.
I think institute support is very essential, and you need a very clear conflict of interest policies. What happens is there will always be some people who will misuse some of these, and because of them, then we start making rules, just to prevent that misuse. In the process, things become so complicated that nobody can do anything afterwards. So I think very clear conflict of interest policies are important, because whenever you bring together two different sort of things like Saraswati and Lakshmi together, are always going to have a problem, and that is where you need those clear conflict of interest policies, and at least the seed grants from the institute, from the university, will go a long way. And after that, of course, they can go out and receive funding from various other agencies if the ideas are good, and of course anybody will fund them. But initial phase, I think some seed grants are important for them to have from the institute. So I would say, a kind of structured schemes with funding available from the institute, and also clear conflict of interest policies. So these two things, are very important for entrepreneurship to thrive on an academic campus.
Thank you, Professor.
Yeah. Sir, there is a question from Sashikala Karthi. So, NPK sensors, please elaborate the startup requirements relating to NPK sensor.
So we have developed it using electrochemistry kind of principles. And if you write to me, if you have any interest in that, I can put you in touch with the startup. Soil Sense has developed it. Recently, they have demonstrated that in one farmers mela and all that. And I think if you check the Soil Sense website, soilsense.com, and Dr. Rajul Patkar is the CEO of the company, so she can share with you all those details. If there's any issue, you can always contact me. I can put you in touch.
Sir, can I ask one question?
Yeah, please introduce yourself because we see only some identification number. So you may.
Yeah, I already raised and unmuted. Okay.
Yeah, you may raise. Yeah.
Professor Rao, this is Dr. Silkuri from VIT Vellore, School of Electrical Engineering. So my question is, the funding is very critical for any research, especially if it is going to become a commercial product in the future and down the line. But the many reviewing body and funding agencies, their approach, especially the Indian mindset is, okay, unless you publish paper in this area, we are not going to fund you. Or they have a doubting mindset. So if anybody has an idea, innovative idea, if that product or a solution is not available in industry, that publishing a paper is a prerequisite to get a funding. Because if you have an idea, if you come up with a solution and before you publish, you want to patent it. But I have not seen this kind of mindset in funding agencies, including DFT. And I am sure that many institutions in India, they are having this approach. Before funding, they want to see some results from you. And if you publish already your ideas, I don't think nobody is going to fund you anymore. So how do you address this challenge? This is already a big challenge in many institutions. I don't know whether it is a problem in IIT or not.
Challenge. Even as a researcher myself, when you are wearing two different hats, I think this problem will arise more and more often. And I tell you, I think without publishing papers, you cannot be an entrepreneur in academic system. As a professor, if you say that I will not publish, I will only, work on patents and products, you will have a problem. I think a lot of background noise.
Gopi, could you mute others?
Yeah. Yes, so I think you need to be able to manage both. For example, in my case, if you look at my own way of doing things, I picked up problems which also require deep technology to develop. And on the technology platforms, I write lots of papers. I still, during my peak, I used to write about 30 papers every year. But I also file patents before I write those papers. So I think you need to be a good researcher and be able to publish in good journals, good places, and then slowly you file patents, and then you approach funding agencies saying that I have these patents, I have these publications. Now I want to, I want this funding to develop a prototype and all that. And DST also is not the right agency, for some of these. The regular program advisory committees will not have, that sort of a orientation. But there are other committees of DST and also the BIRAC. If there is a bio component, BIRAC is the one, and the Technology Development Board. Some of these agencies, have a better mindset to fund the prototype related kind of projects. So you need to approach the right kind of an agency. And but I think we have to be able to publish. And I think being in an academic institute, it doesn't work if you stop publishing, because who are our major, the resource for us to carry out research? These are PhD students, and for PhD students, they have to publish it. So I think, at least I manage most of this research through PhD students who are stable, and you get good students. So publications, patents need to always go hand in hand, kind of.
Sir, there is a question in the chat. So, is there a time limit for a startup? It is from Vardarajan Sabrish. So, what is the maximum time, number of years can a startup exist and sustain? Can a startup company be converted into a normal standard company? So, it's a generic question. So,
depends on I think according to the Government of India definition now, the startup, I think 7 years.
10 years. 10 years.
10 years now. After 10 years of incorporation, it won't be called a startup. It used to be 7 years. Now they have made it 10 years, which is good. So I think after that, it won't be called a startup. So, but how long will you survive? Depends on your idea, depends on how much of investment are you able to generate. For us, for NanoSniff, it took us, a bit of time to turn positive in our balance sheets. But now with the investors and with the product out in the market, I think things are fine. So that's the reason why I mentioned it's good to, mature the technology in an academic kind of a setup before you start a company. Because once you start a company, then the clock starts ticking. Raising funds in the company is more difficult than raising funds as a professor. So that problem also will arise.
Sir, you mentioned you have a hard stop at 12:30. So,
I know. Unfortunately, I need to leave, but another, maybe 5 minutes is okay.
Okay, fine, sir. So there is another question from a research scholar, Sudhakar, interested to work on computer vision in agriculture, nutrient deficiencies in crop. Kindly suggest some of the best resources to study the existing models and gaps.
Of course, you need to find that there are many. I mean, these are things which, the first thing that you need to become an entrepreneur is the right kind of a problem definition, a market survey. So I think, you need to figure out all of that. And I personally feel precision agriculture is a very important area, a ripe area for innovation. But I started working on it about 5 years ago. So now we have products in the market. So you need to pick up these problems early and then, reach the market soon enough so that you can sustain the growth and all of that.
Sir, Professor Kanchana, Provost Chancellor, Chennai campus, she wants to ask a question.
Sir, good afternoon, sir. Good afternoon, sir. Great listening to you. Highly informative session as always, sir. Sir, please let us have some input on the electronics manufacturing status in the country, sir. Even more than oil, we may have to spend on electronics. So even if not the whole IC flow, what is going to be the status, sir?
I think from a startup point of view, for the sensors, the facilities are now available. You can manufacture all the micro sensors in the country. For example, we manufacture for both the soil sense and NanoSniff. We manufacture some of them in SCL in Chandigarh, and they have a good MEMS fab. We also have a prototype manufacturing facility at IIT Bombay, and we also have one in IISc Bangalore and IIT Delhi. So all these places now have excellent micro nano fabrication facilities. So there we do most of our fabrication thing. The semiconductor manufacturing, those mega fabs, I think I'm sure you must be following
Yes, sir.
that's a separate thing. But from a startup point of view, what you need are currently available. We struggled it initially, but now we have set up those facilities. I think they are available for all researchers in the country.
Yes, sir. Thank you.
Thanks, sir. So one last question. So from a PhD scholar, as a motivated PhD student, how to transition from library-based problem to real-life-based problem? What would be the good starting point?
I think starting point is to, connect with people outside of your comfort zone, which is very important. We like to talk to the same people every day, and that you need to, come out of. And for example, talking to a farmer, and then going to a village, spending time with a farmer, just understanding of how agriculture is done, or go to a hospital, stay with the doctors, understand how they do how they manage the outpatient kind of thing, or what are the kinds of things they do and what do they require. I think put yourself in uncomfortable situations, and that is how you learn more. That is how you get new ideas. That is how your mind opens up to the problems in the society. I think that's the first step. Now, I always tell my students that if you just interact with the same people, day in and day out, you are not going to suddenly become an innovator. I think that won't happen. So I think we need to put ourselves in those uncomfortable situations and learn from all these different stakeholders who we normally don't come across on our campuses.
Yeah. Thanks a lot, sir. And I would request Professor Ramgopal Rao, Dean Academic Research and also a member of a faculty startup committee, to propose a formal word of thanks.
Thank you, Dr. Bala. It's my great pleasure and privilege to thank the Professor B. Ramgopal Rao, spending the valuable time and enlighten us through the faculty as a startup founder, and he has taken his own the experiences and the pathway to guide us in the right direction. How the faculty startup has to think about in the academic environment. In fact, Professor has started from the current status of the Indian R&D, and then how our the societal problem to convert as a project, and also Professor has addressed the important area that is the research in India, especially in the sensors where the faculty are working, and what is our the share in the international arena in terms of the fifth and the third position in the AI and ML domain. So it is a great motivation for us, sir, especially for the very important the strategic level of the technological areas. How to choose the problems in the academic environment. In fact, one of the research scholars has already raised that the specific aspect you are rightly put. And in the academic level of the curriculum, we introduced the introduction to innovation project for our the undergraduate students, and also take answers for the real world problem statement as a project based course as a mandatory. In addition that, we also introduce undergraduate research experience. They can work along with the faculty to take up the industry and the societal problem for the period of 6 months and the 1 year, and they can convert as a credit points. So we are closely working with the Robert Bosch and the Samsung Prism, that is a preparing and inspiring student minds for the first 3 years. And many of our the projects got the excellent award under the industrial level of the organization. And also we are closely working with the Honeywell on the sensor domains. In fact, whatever the direction that you have pointed out, I recollected during your visit in the Senate 2007. So you address in the keynote talk on the cardiac diagnostic for the our the sensor and the networking conference, where you have highlighted the importance of the sensor. And that is the very important motivation for our VIT faculty working more on the sensors domain and also for the digital healthcare. So hope we are in the right track, and we will be keep requesting you are the guidelines and the support in all our the future activities. Whatever the 5 T's that you have addressed, that is a very, very relevant to the today's technological institutions. Hope all over the faculty and the student friends enjoyed your talk, and it is really indeed a great level of the support for us to move ahead how the faculty and the research scholars to take their footsteps in the entrepreneur journey. So on behalf of the VIT Technology Business Incubator and the VIT University, we thank you, sir, for your the time and the support for the excellent talks.
Thank you. Thank you.
Thank you. Thank you. Thank you, professors, and thank you, students.
Thank you, sir.
Thank you.
Thank you all. Thank you.
Thank you, sir.